Hello, this is Li Wei again. Now let's look at example number 2 for Bode plot. Example number 2 for Bode plot. Okay, so in the second example, so we want to sketch the Bode plot. Of this transfer function. Okay, so first, in order to sketch this Bode plot of the transfer function, we need to manipulate this transfer function into standard form. So for this transfer function, we have three factors. So 50 is a constant, j omega is the so-called a pole, which is 1 over j omega. It's actually 1 over j omega is the so-called pole at the origin. A pole at the origin. So the third factor is 1 over 5 plus j omega, which is a first order pole. Okay, we have these three factors. So here, factor number 3, it is not in standard form. So first we have to make it standard form. So in order to make it a standard form, so the zero order term now is 5. We have to make 5 into 1. That means we have to divide 5 for numerator and denominator. So here we have 1 plus j omega over 5. And here we have 1 over 5. And here, basically, this guy and this guy, they can cancel. It will be 10. So we have 10 times 1 over j omega times 1 plus j omega over 5. Okay, so we have three factors. So the first factor is a constant. So the second factor is a pole at the origin. So the third factor is a simple pole. So let's first plot the magnitude of the transfer function. So in dB value. So first, the magnitude of the transfer function in dB value by definition is 20 log base 10, the magnitude of the transfer function. So basically, logarithm convert the multiplication into summation. So that means we have 20 log base 10. So for each factor, we take magnitude and we sum up the dB value. Okay, so here, so we have factor number 1, factor number 2, factor number 3. So let's plot the magnitude for each factor in the Bode plot. Okay, so for factor number 1, it is constant, so it is 20 dB. 20 dB. So for factor number 1. So for factor number 2, it is a pole at the origin. So a pole at the origin is a straight line with a slope 20 dB per decade. So the straight line will cross frequency axis when frequency omega is equal to 1. So it's cross when frequency is equal to 1. So if I assume the frequency starts from 0.1 to 1 to 100 to 10 to 100. Okay, so this is frequency is really a semi-log plot. The frequency is in log scale. Okay, so for factor number 2, it's a straight line with the slope minus 20 dB per decade. It cross the frequency axis when frequency is equal to 1. Okay, let me plot it. Okay, so this is factor number 2. So for factor number 3, basically it is a first order pole. So for first order pole, we have two symptotic lines. So when the frequency is really low, we have 0 dB. When the frequency is really high, we have a straight line. So the straight line will have the slope of minus 20 dB per decade. And these two symptotic lines are crossing at the corner frequency. So here, basically, corner frequency is 5. Okay, so let's first put the corner frequency. So corner frequency is 5, somewhere here. So when the frequency is really low, basically this j omega over 5 is really small. So we only have 1 here. So 1 over 1 give us 1, and the dB value is 0 dB. So when the frequency is really low, when it's lower than the corner frequency, we have 0 dB. So when the frequency is high, basically, so 1 in the denominator can be ignored, because when the frequency goes very high, so basically we will have for factor number 3, we will have a straight line, and the straight line will have minus 20 dB per decade. So it will have minus 20 dB per decade. Okay, so this is the Bode plot for factor number 3. Is a first order pole. Okay, now we are going to sum them up. So we are going to sum up the dB value for factor number 1, factor number 2, and factor number 3. So we go from the beginning. Let me change the color here. Okay, let me go from the beginning. So in the beginning, factor number 3 has 0 dB. Factor number 2 is a linear line with slope of minus 20 dB per decade. So the slope is minus 20 dB per decade. So here we have factor number 1 is 20 dB. So we have factor number 1 20 dB, factor number 2 in the beginning is 20 dB. So we have 40 dB. So it's really, so if we use factor number 2, it's a straight line, add up to factor number 1 is constant 20 dB. That is equivalent that we move the dB value is the linear line for factor number 2. We move it up, we shift it up by 20 dB. So we can shift it up by 20 dB. So that is when we sum up factor number 1 and factor number 2 dB values. So until we reach to the corner frequency 5, when omega is equal to 5, until we reach to here. So, and from this point on, so factor number 3 will take effect, because in the beginning factor number 3 has 0 dB. From this time, from frequency equal to 5 on, so factor number 3 will take effect. So for factor number 3, because the slope is minus 20 dB per decade. So that means, so the total dB value will bend down by minus 20 dB per decade. So in the beginning, the slope is minus 20 dB per decade. So from omega is equal to 5 onward, so the slope will further bend by minus 20 dB. So the total slope will be minus 40 dB per decade. Okay. So the total slope is minus 40 dB per decade. Okay, so this is the Bode plot for magnitude plot. Okay, so let's look at the Bode plot for phase angle plot. The phase angle plot. Okay, so the phase angle, the total phase angle phi, so we have three factors. So we sum up the phase angles for the three factors, give us the total angle. So for first factor, is 10, so the phase angle is 0. For the second factor, the phase angle is minus 90 degree, right? Because it is 1 over j omega. So it is 1 over j is equal to minus j, which has minus 90 degree phase angle. So for the third factor, so the phase angle, let's write here. So the phase angle for the third factor, so it is first, it is minus the phase angle of the denominator. So it is minus the phase angle of the denominator, 1 plus j omega over 5. The phase angle of 1 plus j omega over 5 is inverse tangent function omega over 5. Okay. So let's plot it. So we have two terms. So the first term is minus 90 degree. The second term is minus inverse tangent function omega over 5. So let's plot the phase plot for each one. So for the first factor is minus 90 degree. So it is minus 90 degree for the first factor. So for the second factor, it is minus inverse tangent function omega over 5. So if we remember, so for the second factor, so we have first, when frequency is equal to 5, when omega is equal to 5, so let me mark the frequency axis. So we go from 0.1 to 1 to 10 to 100, and then when frequency is equal to 5, so let me mark it here, when frequency is equal to 5, okay, when frequency omega is equal to 5, inverse tangent function 5 over 5 is equal to 1. So inverse tangent function of 1 is 45 degree. And we have minus sign before it. So we have minus 45 degree. So minus 45 degree. So when omega is equal to 5. Okay. So when omega is really small, it is 10 times smaller than the corner frequency 5. So which is 0.5. So 0.5 is somewhere here. So when frequency is omega is less than 0.5, so the phase angle tangent, so inverse tangent function of 0.5 over 5, the phase angle is 0. We assume it is very small. Yes, phase angle is 0. So when frequency omega is larger than 10 times of the corner frequency, so when omega is larger than 10 times of 5, which means omega is larger than 50. So when omega is larger than 50, so 50 over 5 is equal to 10, inverse tangent function of 10 is very large, is close to 90 degree. So it is close to 90 degree, and because we have a minus sign before it, so we have minus 90 degree. Okay, so the phase angle here is minus 90 degree. Okay, we can connect in between, we can connect the 3 points to approximate the mid-frequency phase angle. Okay, so this is factor number 2. So we had factor number 1, and we have factor number 2, and we sum them up to get the total phase angle. So we go from the beginning. In the beginning, factor number 2 have phase angle 0, and we only have phase angle for factor number 1, it is minus 90, until we reach to 0.5. So the phase angle of factor number 2 will come into effect. So we have to bend down here. So for factor number 2, the slope is minus 45 degree per decade. Minus 45 degree per decade. So we have to bend down minus 45 degree per decade because of factor number 2. We have to bend down and we move on until we reach to frequency omega is equal to 50. So from here, so basically we have factor number 1 add up to factor number 2. So here minus 90 add up to minus 90, we have minus 180 degree. So basically here is minus 180 degree. So which gave us the Bode plot for phase angle plot when we sum up the phase angle for factor number 1 and factor number 2. Okay.